So I got a lot of 3D printer parts here and a CTC Prusa i3 MK2 3D printer in the corner. Because I'm going to convert my CTC Prusa i3 MK2 3D printer into a more realistic Prusa i3 MK2 3D printer clone, coming up on Zachary's 3D Prints. Hello, this is Zachary from Zachary 3D Prints, bringing you how-to, reviews and many other cool things you can do with 3D printing. If you're new to this channel and not subscribed yet, please consider subscribing. You can also follow me on Instagram, Twitter, Facebook. I will put every social media link that I have in the description of this video. You can, if you want, support this channel as well. I will put the Patreon link in the description of this video. So, as you can see, I've got a lot of 3D printer parts here, also 3D printed parts here, and I made some preparations in the last few weeks. Printing, cutting, test fitting or dry fitting that I usually would say, and these parts are almost done to put together. And like I said, I was dry fitting everything, so everything should be almost good to go to assemble. There are some few parts that I couldn't get on time ready, like the 3D printed box for the PSU. From Prusa, the PSU is smaller and it would fit better into the standard printed part. Well, on my MK3 I got a cover with also a power inlet and a on-off switch. Well, I looked around and I found an old power supply unit from a computer with a power socket and also a switch. So I solder everything together, and not everything because I still need to put the wires through the socket holder. So I still need to solder this together, but that I will do in another video because I need to design it and also 3D print it. So that one is going to be later in a later video. I also, when I'm going to design it, I have to make sure that I'm using those screw holes and no screw holes here, because those are going to get onto the frame. So I'm going to put this one aside. I'm not going to use it. Also, for the main board is too big and it doesn't fit into the main board housing. As you can see, there is here a hole for the USB, and that doesn't fit that well because the board is too big. So I'm going to order a real Rambo board for this one, but until then I'm going to use some alternative for that. Also need to design it as well. So why did I get this idea to going to rebuild this MK2 3D printer? So a few weeks ago I posted a video replacing the build tag by steel sheet, and when I was doing that I wanted to add one more linear bearing into this holder, and as you guessed it, it snapped off. No big deal, we can 3D print it again. Because I didn't have the file on hand, I had to search for it, and I thought maybe I can 3D print all i3 MK2 3D printer parts in the original colors like orange and in black, and I think it looks quite awesome. I had to make some modifications as well. For example, these lead screws have a pitch of 2 millimeters. So I had to design a adapter because the lead screw nuts were a little bit tiny and they wiggled all around in the hole and it didn't fit. So what I what did I do? I went to Fusion 360 and took some measurements and start designing it. Well, it's a tight fit and it's nice together, just like it should be. Well, I pre-assembled this part and also the other one. I hope you don't mind. So a few things that I had to do before I could assemble everything. When you start building this MK2 3D printer, I'm using old screws that I got from my CTC I3. So as you can see, this is the frame from the old CTC I3 MK2 3D printer. This side is from the main board and this one is from the power supply unit. It's a little bit bended, but for that what I'm going to do, it's no problem. Well, I'm going to put this aside because I need to re-drill some holes, and that I'm going to do in some time lapse later. Now let's start with the Y-axis. As you can see, my heat bed is a little bit different, but in the future I can upgrade this and exchange it for a original Prusa one. So I'm going to put this one aside and also need to use this one when I did change it. Let's build it. Well, we have a lot of threaded rods, but let's start with the smallest one, the M8 ones. When you are cutting it, make sure that all threads are nice, smooth, and the nuts are going over it easily. Let's move the camera to here and then I'll show you the whole process. Let's build the parts. Let's move those old pieces away. So let's start with the back side. Then a nut in a washer, or a washer and then a nut. I'm getting nuts here. Can somebody help me? Just tiny twists and it should be okay. So that is the first part. Let's go to the other one and let's do it in time lapse. So as you can see, I've got it installed here. I think I switched this one to the wrong direction, but it doesn't really matter because this looks also very nice, and it's for holding the timer belt pulley. So now we are going to install the threaded rods. So these threaded rods, the M10s, came from the CTC I3 MK2 3D printer, and I just took a little part off. As you can see, it's 92 millimeters, and these are left over. Well, now we are also doing the same thing here, also adding washers and nuts. Keep in mind that from this part until the Z frame is 100 millimeters. Now let's continue. So now we are going to install the stepper motor for the y-axis. Well, we take first the pulley off and then put the new one on and then put it off. So I ordered some new parts from a shop here in the Netherlands, and there I can buy these 3D printer parts. Very handy. So the pulley goes on. This is G216. There are 2 screws on the pulley, so something like that. Well, Prusa uses different kind of connectors on their NEMA 17 motors, and these are way too big. So if I am going to do this, it doesn't fit. So what I can do, I can leave it like that, or I can twist it 180 degrees so that the connector is on this side. And then we can lead the wire to the back side. Well, first I did makeshift my own Allen screws. I did use a thread tool. I don't know if I call it correctly. It should fit. I'm going to fit the motor onto the bracket. So the battery from the camera from the iPhone was almost empty, so I have to do it without a clip-on microphone. So okay, what did I did in the meantime during the time lapse? Well, as you can see, it's pretty much installed. I did install the stepper motor for the y-axis, also the end stop. The end stop that Prusa uses is one without this metal piece, and the clicker should be here. I don't know if you can see it, but there's a little notch here, and the notch should be on the same spot as the clicker. So also I did notice that the stepper motor was way too much on the other side, so I had to measure it again, and now it's on the 66.0 mark. And also this one I also adjusted a little bit more. Those two should be in one line. I don't know if you can see it, but it's looking pretty much okay. For the assembly instructions, there is a moment that you should add your heat bed onto this frame. I'm not going to do that at this moment, so I also leave those bars in. I'm not going to take them out or strap it into it. Let's add the Z frame. As you see, it's from the CTC I3 printer. I'm going to reuse it. In the meantime, I also am going to order a metal frame and also a metal frame for the heat bed. So this part is going to be exchanged, but not at this moment. I'm going to use it, and I need to drill some holes so that I can use the 2 ZX motors further down, and that it is also standing on the motors instead of hanging in the air. So I'm going to put this one aside, just here on the ground, something like that. So I'm going to put it upside down like this. So as you can see, everything is so far so good. What I need to add to this whole Y and Z frame building, on the top you have to drill some holes. Make sure that your stepper motors are as horizontal and square as possible with the rest of the frame. As I mentioned, I was doing a dry fitting and I pre-drilled some holes, but on this side it's not the right height as this one. For the building itself, it doesn't really matter. In the future I will exchange the Z frame for a metal version. So let's put this on the side. As you can see, it's pretty steady. I also did a re-measurement to make sure that on one side it's 100 and on the other side of the frame is 185. So now let's continue with the X gantry. So that is the motor end, the other end, and the two longest smooth rods. Well, we have those two ends and also the extruder gantry itself. Well, I already prepared it. I was using one normal lineal bearing and one longer one. I don't know which kind of size this is, but it's the double size. Make sure that every lineal bearing is running smoothly over the rod. This one is okay. I noticed some resistance here, so I need to make sure that I have an other one. Ooh, oh, that goes fine. That is nice. Nice. So that one goes in the top. You can also put two of the smaller ones, but I'm going for this configuration. Just like that. Put it in. And then we are going to strap everything in. So it's going to look like this. This one goes in there. Then we add this. When you are going to print this, make sure that you use small screws on the end. This is to make sure that the gantry can be adjusted just a little bit. There are some modifications for this one, like a belt tensioner for the X-axis, but I'm not going to use it in my 3D printer. Also, when you are going to do the bearings in here, I already prepared it. Make sure that one line is like this and one line of bearing is like that. So there's a little bit angle there. Okay, just not the same way as the other one. I also did it by this one, and now we are going to continue. We need a stepper motor for the X-axis. We pull off the old gear and we put on a new one. Make sure that the pulley is on the right side. If not, you can always switch it. Let's go into the time lapse. So during the time lapse, my memory from the iPhone was as good as full, and so the time lapse quit. So what did I do in the meantime? I added the motor part. When you're going to put the timer belt on the gantry, make sure that you only screw one of the 3 screws into the motor. Then when you are going to do the timing belt in, Start on this side first, then go all the way here to the end, and then over the pulley back into here, and then over the motor, and then put it here. Make sure when you tension it that this is easily to put together, not too much tension on it. You can put a little bit more tension to it by turning those two screws. Further, I think when I'm moving this one, I think it's quite smooth. So that looks nice. Well, let's take the machine, let's take the printer, and let's see how it looks like. Well, I think it's already looking amazing. Let's put the gantry onto the top of it. So as you can see, I added the two brackets for the Z-axis. For display purpose, I added the display and also the heat bed. It's running quite smoothly and it's nice. That are all the things that you can do with 3D printing. Well, to wrap up this video, today I started with the conversion from my old CTC I3 MK2 3D printer to a more realistic Prusa i3 MK2 3D printer with original parts from the site of Github. I'll put the link of that in the description of this video, and there you can print in many different kind of colors. I choose for orange and black as in the Prusa colors, and it's looking awesome. Well, that being said, thanks for watching. Please like this video, subscribe to Zachary 3D Prints, and hey, let's make some fun with 3D printing. Zachary 3D Prints. Bye bye.